The next method that we want to look at when we talk about graphing equations is using slope-intercept form. This comes from section 3.4. In order to do this, you do need to be able to find and plot the y-intercept of a linear equation. You need to know how to manipulate negatives inside a fraction, and you need to be able to identify points in the rectangular coordinate system. Upon completing this presentation, you will be able to identify the y-intercept and slope for an equation in slope-intercept form. You will be able to use the y-intercept and slope to graph a linear equation and identify points in the rectangular coordinate system. So to start off with, what is slope-intercept form? Our formula is y equals mx plus b. Many of you probably remember this formula. It might be the only formula that you remember from math. So what does this tell us? This tells us that 0, b is the y-intercept and m is the slope of the line. So what is slope? Slope is the ratio of the vertical change to the horizontal change. There are many ways to define or think about slope. We will explore other definitions when we talk about manipulating equations. But one of the first ways that we can think about this is we can use the memory tool rise over run. Rise tells us how far up and down to go. Run tells us how far left or right to go. Our favorite form for equations of lines is slope-intercept form. If you are given an equation in slope-intercept form, you will eventually, if not already, be able to sketch what the graph looks like without doing any computations or plotting any points. You can determine whether the y-intercept is above or below the x-axis. You can determine if the line goes up or down from left to right. You can determine if it is a steep or shallow line. The other nice thing about graphing lines in slope-intercept form is that it is a very hands-on technique. There are no calculations involved. You just need to be able to count. So our procedure in order to graph lines in slope-intercept form, we want to start by plotting the y-intercept on the y-axis. Remember, the y-axis is the one that goes up and down. We want to write the slope as a fraction if necessary and identify the rise and run for the given slope. From there, we want to start at the y-intercept, or technically any point on the line, and use the rise and run to obtain a second, third, fourth, however many points you want. From there, we want to label each point. To find the coordinates of the second and any other point, make sure that you determine its location based on its location from the origin. Also, remember that in order to find the coordinates of a point, you want to go left and right first, and then up and down. A lot of students get confused because slope is up and down and then left to right, and it's the exact opposite from how we determine the location of points. So let's look at some examples. If we look at example A, we have y equals 4x minus 3. So the first thing that I want to do is identify my y-intercept. My y-intercept is going to be 0, 3. If you were to put 0 in for x, my x term would go away, leaving me with just -3. My slope is 4, but I do want to write it as a fraction. This is equal to 4 over 1. Okay, so now if we go ahead and plot something. Let's start with 0, -3. Let's start with our y-intercept. And from here, I want to apply my slope. So remember that slope is rise over run. This tells me I want to go up 4 and 1 to the right. We are going up and right because they are both positive. So if we do this on our graph, we end up with going up 4. Remember to count after you move. 1, 2, 3, 4, and to the right 1. So if we plot that, we should be right here. You can do this as many times as you need. So for instance, from this new point, I can also go up 4, 1, 2, 3, 4, and to the right 1. And we end up right here. So now we can go ahead and draw our line. And we can label our points. So we know that the intercept, the y-intercept is 0, -3. And so now I want to know what is the coordinates of our second point. Our second point, in order to get to it from the origin, remember we want to go left and right first, so I'm going to go right 1, up 1. And so this point is 1, 1. In order to find the coordinates of the third point, starting at the origin, I want to go 1, 2 to the right, and 1, 2, 3, 4, 5 up. And so this point has coordinates 2, 5. Note that the coordinates of the points have nothing to do with the numbers that are in the equation. The numbers in the equation are basically telling us where we're starting and where we're moving, but they don't tell us where we end up necessarily. 4, -3, well, the -3. The 4, you're not going to use it in any of your points. That tells you direction and how far. Hopefully that makes a little bit more sense. Okay, so let's go to example B. Example B, we again want our y-intercept. Our y-intercept is 0, 1. And we have a slope of -3 over 5. The negative in the front, we can do several things with it. For instance, I can put it in the numerator. And if we look at this, what this tells me is I want to go down 3 and right 5. Since the negative is in the numerator, that tells me to move that one in the negative direction. Since my 5 is still positive, that still needs to go in the positive direction. So if we go ahead and graph this, I'm going to start with my y-intercept. My y-intercept is 0, 1, which means that it is 1 above the x-axis. And now my slope tells me I want to go down 3 and right 5. So starting here, I'm going to count down 3, 1, 2, 3, and I want to go right 5, 1, 2, 3, 4, 5. I should end up right here. Now, in the previous slide I mentioned we can move the negative around. So here I can move the negative to the bottom instead of the top. Why would I want to do that? Well, it depends on where you start. For instance, if we started at the very bottom of our graph, we may not be able to go down 3. So what we can do is this. We can go ahead and put our negative on the bottom. Remember that the negative can go wherever it wants, as long as there's just one of them. And what this now tells me is I want to go up 3 and left 5. So picking a point, let's start with our y-intercept again. And let's go ahead and move according to this. So my y-intercept, we're going to start here. And I want to go up 3, 1, 2, 3. And I want to go to the right, to the left, 5, 1, 2, 3, 4, 5. So we should end up somewhere in the second quadrant. When you think about slope, think about stairs. This is basically creating a staircase. And so if we go up in one direction, in order to go down, we're going to have to go the opposite direction. So now that we have our 3 points, we can go ahead and draw our line. And we can label. So I know my y-intercept is 0, 1. In order to get to my right point, we want to go 1, 2, 3, 4, 5 to the right, and 1, 2 down. So this is 5, -2. To get my top point from the origin, I want to go 1, 2, 3, 4, 5 to the left, and 1, 2, 3, 4 up. And so this point is going to be -5, 4. All right, let's look at our last example now, example C, and see what we can do with this one. For example C, we have our y-intercept is 0, -5. And our slope is 3/4. Right now my slope tells me that I want to go 3 up and 4 right. So if we plot 0, -5, we have, this is on the y-axis, we're going to go down 5. And now my slope tells me that I want to go 3 up and 4 to the right. So if we do that, we end up at 1, 2, 3 up, 1, 2, 3, 4 to the right. We should be right here. And we'll go ahead and leave it just like that. We can go ahead and draw our line, and we can label. So my y-intercept was 0, -5, and the coordinates of this new point, if we go ahead and start at our origin, to get there I need to go 1, 2, 3, 4 to the right, and 1, 2 down. So the coordinates of this are going to be 4, -2. And we're done. So hopefully this makes a little bit more sense. As I said, the main thing you want to remember is to make sure that you do not use the slope, for instance, as a point. The slope, all it tells you is direction and how far. It does not have to do with where you land. Slope, another way that you can think about this, we're talking direction. Think about north, northeast, east, west. Those tell you directions. And you can talk about mileage, but in terms of their longitude and latitude never changes. And so all we do with our directions is move from point to point, but those points never change location. So when will we see this again? Slope-intercept form is the form of the equation that will not only allow you to graph an exact picture, but can also be used to sketch. That is something that you will explore more in future math classes, is just sketching a picture. The difference between them is an exact graph is with exact points on it, whereas a sketch is just an idea of what it looks like. When we talk about graphing quadratic equations, we will revisit and expand on many of these concepts. And in future math classes, again, as I said, you will want to be able to sketch the basic shape of different graphs, expanding on some of the concepts presented here. Once you feel confident, or as confident as you can with this material, go ahead and try the following problems on your own and bring your solutions to class, along with any questions that you have. Please take a minute to pause the presentation as you work on the following problems. Once you have completed the problems, go ahead and unpause so that you can go on and move to the next slide. As part of your notes, please answer the following questions and bring to class along with the problems from the previous slide. How confident are you with the material presented in this section? What from this section needs to be explained further? How much more practice do you need to be comfortable with the topic?